Number 4. We were on D, and we were looking at marginal profit of 100 cents. So marginal profit, marginal is the derivative of profit. So we found the derivative of profit, which is pi of x. Then we plugged in 100, and we were at 73. And I think the bell already rang when I fixed it to 73, hadn't it? So that is our marginal profit, which means it's $73, which I never wrote. And then it did ask us to interpret our finding. So this is our marginal profit. What's happening at 100 sets of headphones?
Make $73.
It's increasing at a rate of $73.
Okay, so go back to that whole derivative idea, right? Yeah. I mean, it's marginal profit, but you see that derivative sign. So mine is listed as 100 headphone sets. When 100 headphone sets are produced and sold, the profit is increasing at a rate of $73 per set. When 100 sets of headphones are produced and sold, the profit is increasing at a rate of $73 per set. Okay. E. How many headphones should the company produce in order to maximize their profits? Thoughts on when the profit will be maximized?
When we make the most money.
How are we going to find when they make the most money?
I don't know.
When does a max happen on a graph?
At the peak.
At the peak. And what's true at the peak? I mean, this is where I need us to process here, okay?
It's the highest point on the graph.
It's your capacity, I don't know.
Highest point on the graph.
It's going to go down after that.
Okay.
And velocity is velocity, not velocity.
Okay, but okay, go with this.
Slope is increasing to decreasing.
Okay, what is the slope at that highest point?
0.
Slope is 0, yes? At a max or a min, the slope is 0.
Yeah.
Okay, and I know we're not talking slope, we're not talking velocity, but you were headed to velocity as 0, right? Or I think that's, no, that's true, okay, but slope is 0. At a max or a min, the slope is 0. What is that in equation form? When is the slope 0? When what equals 0?
Y.
X.
The equation.
No.
Wait.
Why are we
Okay.
struggling
What?
so hard?
I don't know. Okay. So how do we set up an equation? Because we're looking for the, what is it? How many headphones? So how many headphones is going to make the slope be 0, basically? Slope, what is slope? Slope is the,
The change in. No, I don't know.
slope is related to what calculus concept? Derivative.
Yeah.
So if we're looking for trying to maximize their profits, we're looking for when the derivative is equal to 0. We were like dancing all around it. I'm
Yeah.
sorry. Maybe I'm not leading you great on this one. I don't know. It just wasn't happening for whatever reason. We weren't seeing each other. Are you seeing it now though?
Yeah.
Okay, you guys said when slope equals 0, slope is the derivative, right? So the derivative of profit, we're looking for when the derivative of profit equals 0. Do we have an equation for the derivative of profit?
Yeah.
We do. We had found it up in the previous part to be 75 minus 200's x equal to 0. Do some math, right? Basically, you're doing 75 divided by 2 100ths. 75 divided by 1/50th. 75 times 50 over 1 is what my brain's doing. So 75 times 50 should give us this answer.
I can't divide this.
I was just, I mean, if you don't want to grab the calculator, then we're going old school. I was thinking in terms of fractions, so I'm going to move my decimal over 2 places. 2 into 7, 3 times. 2 into 15, 7 times. 2 into 10, 5 times. You got one more 0 technically, so 3,750?
Yeah.
Or just grab the calculator because you are allowed to use a calculator here. So how many headphones should the company produce in order to maximize the profit? 3,750. So, and the key is the profit is maximized when pi prime of x equals 0. So I am going to make that statement also. Profit is maximized when pi prime of x equals 0. Company should produce 3,750 sets of headphones. $3,750 sets of headphones. As always, folks, random comment, but be able to explain yourself, right? Be able to put it in words. Does it have to be these exact words? Does it have to be this fancy? No. But be able to put it in words. Okay. Bounce back to example 2. Okay, example 2 is the one that my brain was not handling yesterday. So for the sanity of all of us, I skipped it. I'm ready to talk about it better today. Okay, so they give us a graph. Notice the graph is x versus c of x. And they want us to show the relationship for average cost and marginal cost. Okay, so let's see, a couple of things. First of all, marginal cost. What is marginal cost? Cost of making one more. Calculus-wise, it's equivalent to,
C of x over x.
how about c prime of x?
Sure.
You're doing c bar.
Oh.
You're doing c bar
Oh.
when you do c of x over x, okay? And this is back in your notes, right? If you flip a page, we've slept since yesterday, but marginal cost is c prime of x. So keep in mind, okay, this graph is x, so like x units or whatever, and then c of x is your cost. So this curve here, understand that curve is c of x, yes? Just trying to get us where we're at. And then they've got 100 and 101 units marked off. Let's see. I don't know where I should start here. So Okay. Right here, this point on the y-axis, let's talk about that distance and realizing that that's the cost of 0 units, right? And so this is what, vocabulary-wise, we talk about it as the fixed cost, because it's your cost that exists no matter what. Okay, no matter how many you produce, how many items you produce, it exists no matter what. So that distance right there represents my fixed cost. Okay, you could be talking here about the rent of the building, the insurance to run your company, just your basic cost, you know, whatever it might be. Okay, fixed. Mrs. Sargent can't spell. Well, that's not making life better. Okay, there we go, fixed costs. So that's one piece of information to look at. Now, as we look at this, right here, pick a different color, we have the 100th item and the 101st item. 101st item? Yeah. I want to say 101th. Don't ask me. It's just not working for me. And so, with that in mind, those are those items. These pieces over here on the y-axis are the cost for producing the 100th item and the 101st item. I don't know what my issue is here. So this distance on the y-axis is going to be the actual cost of producing one more item. So that's doing that C of 101 minus C of 100. Okay, so actual cost, or I believe, did we use the phrase exact cost yesterday?
Yes.
Okay, so this is going to be the exact or actual cost of producing, did I say one more? Did I say 100? Yeah. Producing one more item, or in other words, this is C of 101 minus C of 100. Okay, that's that distance there. Okay, I'm trying to think what else I need here. Got that, got that. And I know, of course, Aiden is the one that was asking about this yesterday, but when we talked about exact cost versus marginal cost, and Aiden threw out the word average. And I said I didn't exactly want to use the word average, okay? But when I was doing some double checking, getting my vocabulary straight and everything, the word I often ran into was an estimation or an approximation. So when we talk about the marginal cost, it's an estimation or approximation of that one more item. Now, in terms of what we're looking at here, okay, so right here at 101, this value on this curve is the actual cost at 101. Realize this, okay, well, what is that line right there? That line, it's the tangent line going through the point at 100, right? And so right there, we're looking at, there's that small increase right there, okay? But we're looking at the marginal cost when we start looking at that. And which way do I want to mark it? So if we start, it gets hard to mark all of these, distances, which is what I'm trying to do here. But when we look at the 101st item versus the 100th item. So this distance right from there to there, okay, if you can look at those two lines, that is your estimated marginal cost. And I can't spell again. Now I can't spell marginal. Maybe I'm just trying to write my words too fast. And I think that's most. Okay. I think I have most everything. Yeah, just right there. I was just looking, I had mentioned that that's just a small increase right there. And that in general, we're talking about right here, C prime of 100, and that's going to represent your marginal cost there. So, okay, did I get everything that I wanted to get? I think I did. Okay. So hopefully that gives you a little idea of, what you're looking at the graph, realizing there, we also keep in mind you see instantaneous rate, right? This right here is your C prime of X because it's your tangent line at the point of 100. So that's your instantaneous rate of change. I didn't really talk about it here, but this is also, you also see the secant line, the line that goes through 100 and 101, and that would be your AROC, your average rate of change there. Okay, yeah. I don't really have anything labeled for it other than, I guess it would, doing it, not dividing it, but that distance between finds the exact cost there. Okay? Okay. So those are the pieces I had. Again, I just wanted to cover some of it, but I knew if I tried to explain it yesterday, all the vocabulary gets jumbled in my head, and I did not have it straightened out. So, okay. Anything else? Okay. Let's move. I was going to say let's move to 5, but actually we need to move to the bottom of page 221. Marginal cost, revenue, and profit. So we're going to look a little bit of a graph there, and then we're going to go into talking more about revenue. I know we talked a little bit about revenue on the previous problem. So in the graph here shown at right, notice the break-even points occur where the revenue equals the cost. So I talked yesterday, there is a difference between revenue and profit, right? They're not the same thing. Okay, revenue is just all of your income. Okay, profit is that portion of your income after you take out your expenses, right? And so they throw out the vocabulary break-even points, and notice break-even points are right here, and those break-even points, so we have our cost function, which is a straight line. We have the revenue function, which is the parabola, okay? So your break-even points is when your cost and your revenue are equal. Anything above that is going to be profit. Anything before they equal, that's going to be loss. And that's what's represented in the red versus the green, okay? Let's see, how much of this? A company would obviously be most interested to know how to maximize profits. The maximum or minimum profit can occur, and notice right there it talks about where marginal cost equals the marginal revenue. So in other words, where C prime equals R prime. However, maximum or minimum profits do not necessarily have to occur at those points. They can also occur at end points, okay? So when we talk about maximum or minimum profits, it can be where marginal revenue equals marginal cost, or it can also be at the end points, okay? Consider the slopes of the tangent lines. Then when the marginal cost is less than the marginal revenue, a company will take more in extra revenue than it will spend in extra cost by increasing production. So, try to remember what the key piece is. So when marginal cost is less than the marginal revenue, okay, then the company, so your costs are less than your revenue, company is taking in more extra revenue than it'll spend in extra cost, and does that by, key thing there is increasing production, okay. And that would be a key point. I forget which, it comes up in one of our upcoming problems, okay. So I'm sure we'll come back and talk about that problem, or that information. Okay. Let's look at example 5. An office supply manufacturer produces spiral notebooks for interactive student notebooks. Find the quantity X that maximizes profit if the total revenue and the total cost are given in dollars. Okay, so they give us a revenue function, they give us a cost function, where X is defined to be between 0 and 1,000 notebooks. What production level gives the max profit? What are we going to need to know here? Derivatives of both of those, yes? Okay, so let's start off finding the derivative. R prime of X is going to be 0.008x, okay. C prime of X, 1.2, yes? Okay. And I guess I define that as R prime and C prime. That's also marginal revenue and marginal cost, yes? Okay. Now, it's asking for max profit. When does max profit happen? Not when it equals 0, but when they equal each other, right? So max profit happens when marginal revenue equals marginal cost. So we're going to take our equations and set them equal to each other. 8 minus 8 thousandths x equals 1.2. Do some math. Negative 8,000 x is going to be equal to negative 6.8 when I subtract over the 8. And then I'm going to divide. And I can divide it out by hand. I can divide it out by the calculator. But I'm going to get x equals 850. And what is that? Yeah. That is where, according to our math, supposedly, that's where the max profit should happen. Yes? Now, with that in mind, okay, and I think it just says what production level gives the max profit, okay, and that's officially all we have to do. I have kind of over here off to the side kind of a check, and so what I want to go through and try and do real quick, just trying to think logically here, okay, if this is indeed the max profit at 850, okay, what I did in my check is I looked at, okay, what happened at 849 and what happens at 851. Okay, keep in mind, if it is the max profit, marginal revenue and marginal cost are equal, right? Now, where do I have, I'm confused here. Where did that number come from? Ah, that's where that number came from. Okay. Sorry. So if we look at 849, right before the max profit should happen. Okay. Well, if we're looking at that, what would be our marginal revenue at that point? In other words, take 849 and what? You're probably going to have to grab the calculators, folks. Or I guess I can continue to just tell you the numbers, but take 849 and plug it into the marginal revenue.
Yes.
Okay. Do some math. What are we getting for the marginal revenue?
1.2.
Yes.
Okay, so I'm going to put that, since we're talking money, as 1.21. Okay. What is our marginal cost?
1 point.
No matter the X value, our marginal cost is 1.2, yes?
Yeah.
So what do we know? 1.21 is going to be greater than our marginal cost, agreed? Now let's do the same thing for, let's go on the other side of our supposed max profit, 851. If we plug 851 in, what do you gain for your marginal revenue?
1.192.
So 1.192. So if I go money, 1.19. What is that related to my marginal cost?
It's less than.
Okay, it's less than. Okay. Is this making sense that our max profit would happen at 850 then?
Yes.
Yes.
Okay. Okay. Other than that, now, it says what production level gives the max profit. It doesn't ask what the max profit is, does it? But I have that in my notes. Why do I have that in my notes? Just because I felt like it? Probably. Okay. Let's find the profit at 850. How do we find profit?
Revenue minus cost.
Okay. In order to find the profit at 850, you are doing just that. You're going to do the revenue. So the revenue at 850 minus the cost at 850. So revenue at 850. Now remember to go back to your original revenue function. I'm not asking about derivative.
$3,910.
Okay. What about the cost at 850?
1,720.
Okay. And so when we subtract those two numbers, we're going to find a profit of
2,190.
2,190. Okay, so producing 850 spiral notebooks, is that what it was? Is going to maximize profits at $2,190. Okay. Producing 850 spiral notebooks. Will maximize profits at pi of 850 equaling $2,190. Okay. Moving along. Table below shows cost and revenue for the production of a widget. Use the table to answer the following questions. So you have X, so you have the units. You guys have heard widgets before, right? It's
Like the thing on your phone.
Yeah, there's a widget thing.
There's like widgets on the phone.
Where's that?
I don't think of that as a widget, honestly. I think of as a widget as just a random made up thing that you've seen in math. I've seen in math problems for years, like before widgets on cell phones existed. Now, is it? Do they really mean an actual widget? I don't know. I've always just thought of it as kind of a fantasy like item, like we're just going to use this made up name of an item.
I think it's like a doorstop, but it's a way.
I just think of it as it's just a made up item for the problems. I don't know now. Because that's true. It is a thing on the cell phone. I just don't know. Yeah. Okay. So we have X. So that would be our number of widgets. We have R of X. So that is the revenue at each of those numbers. And we have C of X, which is the cost at each of those numbers. Yes? So what would you say is the price of the widget?
$800.
I disagree.
What's the cost of one?
I disagree.
What? Of the widget.
One, whatever. Hang on.
How much they're selling it for?
4, 5.
Is that what they're asking?
$250.
Divided by 2.
Divided by what?
Hold on.
Wait a minute.
Hold on.
What are we doing here?
Hold on. Cost is
Wait, what is
$10.50.
X?
Cost $10.50 to make.
I did minus
They're
the
selling
800.
it.
The price of the widget. So yes. So let me go back and answer a question.
8.25.
What are we selling a widget for? Is the question.
1,850.
No, $8.25.
No.
What?
This would be easier if I knew the size of the thing.
But then you're just
You know if
judging
it's
logic.
Expensive or if
You're just judging logic. Okay. So in each of these columns, okay, we can't really use X equals 0 at this point. Because at X equals 0, none are sold. Thus, if none are sold, there's no revenue yet. Right? Okay. At 200 sold, we have a revenue of $600.
Yeah.
At 400 sold, we have a revenue of $1,200. At 600 sold, we have a revenue of $1,800.
I was thinking it was the profit.
It doesn't ask for profit.
I was thinking that.
Oh, you're thinking the revenue is profit.
So I did 600
so
plus the
600.
1050.
Yeah. So how are we going to find the price of a widget? Revenue is what? How much money you are gaining or not bringing in. Okay. So if we bring in $600 and I sold 200 widgets, or if I bring in $1,200 and I sold 400 widgets, each widget is going to be $3. In other words, in order to get the price of that widget, take your revenue and divide it by the cost. It doesn't matter which revenue you take.
What?
Anytime you do it, it's going to be $3.
Oh.
What did I say?
Revenue divided by cost.
I'm sorry. Revenue divided by the number of items sold.
Yeah.
Sorry.
That's okay.
I could tell I said something wrong. Okay. Are you with me now?
Yeah.
Does that logically make sense now that it's been pointed out to you?
Yes.
Okay. Now, B, fixed cost. What cost do you have no matter what?
800.
When you have produced, we have sold 0 items. We have brought in $0, but we've already had $800 cost. Those are your fixed cost. So when the cost at 0 items, those are your fixed costs. So $800. Okay. At what production level, X, is the profit for the widget maximized?
Well, we're raking in with
What were options about when profit would be maximized? When can profits be maximized?
After the break even. No, that's hard.
Well,
when the cost of revenue.
maximum minimum profits can occur where marginal cost equals marginal revenue, or they can also occur at endpoints. Okay, two things to keep in mind here, yes? Excuse me. As we go back to our problem, how do we find profit?
Revenue minus cost.
Okay, so generally speaking, profit is revenue minus cost, yes? That's just general knowledge there. We don't really have a way to figure out when marginal cost equals marginal revenue here. Okay. However,
I could eyeball it.
well, and that's what I'm debating. I'm like, do I have a better way to tell you other than eyeballing it?
It'd be 800, right? At when X is 800. No?
No.
What? Oh, you're right. 1,000.
You're eyeballing it's not quite right.
I follow.
What's he trying to eyeball that he kind of...
Maybe messed up.
Profit is what? Revenue minus cost. Okay, well, you can't have max profit at 0 items. That's just, forget that, right? At 200 items, revenue minus cost, well, we're still in the negative. We're still at a loss. What's happening at 400? What is that?
Breaking even.
Break even.
There's your break-even point. Okay, where at least now we're going to be past the break-even point. Now, revenue minus cost, 1,800 minus 1,300, just under 500, right? 2,400 minus 1,450, just under 1,000. 3,000 minus 1,850,
Just joke.
over 1,000, right? And that's just eyeballing it in his terms. Okay, so if we look at 1,000, now notice 1,000 is also in this problem an endpoint, yes? Okay, so if you look at pi of 1,000 being equal to, or the profit at 1,000 be equal to revenue at 1,000, whoops, minus cost at 1,000. Well, then we're looking at, what numbers did we just say? 3,000 minus 1,850. 3,000 minus 1,850 is 1,150. And again, as I pointed out, notice that that is an endpoint. Okay? Because max profit can occur there. Okay? Max profit, for my explanation, I just have the facts stated. Max profit occurs when production is 1,000 widgets. And, you know, right there is our information. So, okay, whoops, that got really funky. 1,000 widgets, you know, I don't know. This right here is my explanation. It really is. You know, that work is showing it. I don't have anything extra written here. I just kind of restated that. Okay, where am I at on time?
You got about
I'm in for problems.
15 minutes. I'd say. Not eyeball the clock.
We know how your eyeballing's going today, though.
Yeah.
Do we trust his eyeballing? Okay, with our fifth, I'm gonna skip 7 for the moment. I'll come back if I need to, if time allows. We'll see. I'm gonna skip 7. I'm gonna go to 8 for the moment. Okay. The last examples in our lesson will be focused on other rates of change that are non-motion related. So we're not talking our physics things. We're not talking the business things. We've just got some other motion related or non-motion related, so other rates of change here. Okay. With that in mind, look at 8. Gabby is working on a project that watches the decline in great white sharks in the Atlantic Ocean. The function S of t gives the number of sharks t years since she began working on the project. Find the rate of change for the number of sharks in the ocean after 3 years. Okay. Question asked, find the rate of change for the number of sharks in the ocean after 3 years. What do we need to do?
Derivative.
Yes? Derivative?
Oh boy.
Turn the derivative brains back on. S of t is 3,570 e to the negative 2/10 t.
Just stays that. No. Yeah.
Well, the derivative of e to some power is e to some power. The 3,570, that coefficient just stays out front, right? So 3,570 e to the negative 2/10. So the derivative of e to some power is e to some power
Times the derivative.
times the derivative of the power. What's the derivative of negative 2/10 t?
Negative 2/10.
Negative 2/10. Now, if we're going to clean this up, what should we do? Move it to the front, and you're multiplying 3,570 times negative 2/10, and it's negative some number.
3570.
Negative 714.
Yes.
Negative 714 e to the negative 2/10 t. Okay,
But now,
what were we asked to do?
number of sharks in the ocean after 3 years.
So, plug in 3, yes? Obviously a calculator problem, folks. You're not doing this without a calculator. So, in all honesty, did we have to find that derivative by hand?
No.
Was it good practice?
Yes.
Yes, but, I mean, you can either plug this in.
Really? Oh boy. Oh, there.
I do it on the left.
Yeah.
But you could also have done an inderiv. And just done the derivative of 3,570 e to the negative 2/10 evaluated at
How
3.
do you get 0.8? What?
Okay. Mathematically, the answer comes out to be negative 391.8515108. Now, you have to be careful on that. Because how did they ask for the answer? And it just says find the rate of change for the number of sharks in the ocean after 3 years. I would be very careful in calc that you give, 3 decimal places unless you're 100% sure what they want. However, I will say that I did round to a whole number here. So,
Really have points. Maybe if another shark ate.
but then we're talking about
First of
shark carcasses at that point. So, yeah. So, I have now. So, the shark population, what's it doing? Put this into words for me.
It's going away. It's decreasing.
Okay, I have the word declining. Okay, something negative, right? So declining at a rate of about 392 sharks per year. And this is after 3 years, right? Or at 3 years. Okay. So I'm going to say after 3 years, the shark population I'm going to use the word declining. Get some word indicating you know what the negative means in there. Negative, decreasing, something along those lines. Okay? Declining at about a rate of 392 sharks per year. Okay? Get that word rate in there.
Yep.
Okay, Omar uploaded a funny video of sugar gliders on his Instagram account.
Classic.
I don't make these problems up. The video went viral rapidly. The number of views T days after Omar uploaded the video can be modeled by the function v of t. What is the instantaneous rate of change of the number of views 5 days after he uploaded his video?
I'm not gonna help. Yes.
Yes?
Yeah.
I heard the word IROC. Yes. IROC is the derivative. Okay. So basically, long story short, we're going to want to know v prime of 5 in the end. Yes? This would have been a good problem to skip now that I look at it because
Yeah, we just
v prime of t, that's pretty much the same, isn't it? In all honesty, do you have to find v prime of t?
No.
Can you go straight to the calculator? Is that what Augie's over there doing, maybe?
Yep.
Okay. So, 243 e to the 5/10 t times 5/10 would be your derivative. If you want the updated function for v prime of t, it's 121.5 e to the 5/10 t. What are you guys getting when you plug in the 5? Yep. 1,480.173 is what I have written down. Okay. How are we going to explain this?
After 5 days, video is views are increasing at a rate of 1,480 per day.
Mm-hmm. Yep. So after 5 days, Omar's video views are, notice he threw in the word increasing, indicating its positive derivative. And he threw in the word rate. So at a rate of 1,480 views per day. Okay, moving on to 10. Okay, use the following table of values for the number v of t of gallons of water in thousands per hour h that are flowing into a retention pond t hours after a severe thunderstorm. There was a lot of information given in that stem right there. Yes?
Wow.
Okay, and note, in the table they give me t and v of t, but it talks about v of t being gallons of water in thousands per hour h. And it's flowing into a retention pond t hours after a severe thunderstorm. Okay? Now, the first one asks us, what is the interpretation of v prime of t?
Well, how many
It's a derivative.
How many gallons of water are flowing into the pond per hour?
Not how many are flowing into the pond. At what rate is what we're talking here.
What rate?
Okay, because how many gallons of water is more just V of t. We're talking about the rate. Now, derivative, we could throw in that phrase IROC,
Yeah.
instantaneous rate of change. Okay, so V prime of t, it is the instantaneous rate of change of thousands of gallons of water per hour after t hours flowing into the retention pond. Okay, you've got to throw in that word of rate there. It's definitely helpful. Okay, so V prime of t, I'm going to use the phrase the instantaneous rate of change of thousands of gallons of water per hour after t hours flowing into the retention pond. Okay. How are we going to estimate V prime of 2? What are options? We don't have an equation. We have a table.
Just,
How do we estimate a derivative based off of a table? This is V. How do we do AROC?
Point minus point.
Point minus point, y value minus y value over x value minus x value.
Yeah.
Now, because we're trying to estimate V prime of 2, and 2 is actually a point in our table, I have it as two different options here. You could do it estimating it with 2.5 and 2, or 2 and 1.5. Okay, so with that in mind, I could do V prime of 2. I could use V prime of 2.5 minus V prime of 2, and that would be 2.5 minus 2. Or I could use, I said V prime there, that's not V prime, is it? That's just V. Yikes. V of 2 minus V of 1.5 over 2 minus 1.5. You're going to get slightly different answers. You're going to get 0.18 or 0.44. Okay? And what that is, so that gives us, this is an estimate, right? So it's in between those two areas. Okay? And I know I'm out of time, so there's more I could write there, but keep in mind, these values were in thousands, so that 18 becomes 180.
440,000. Oh no, 440. Sorry.
440, right, because of the decimal.
I
Yeah,
was thinking.
we're all struggling there. Okay, the rest of that, if you need to look at the rest of B and C, is in the notes online. Get your 4.3 done for tomorrow, and we'll go from there. Okay. The quiz review worksheet is open online if you want to take a peek at what you're going to be looking at. So.
I'll surprise myself. I like surprises.